So let me just discuss this with one simple example that we already did for domain of dependence. Suppose we have a system of three equations. When I say that there is a system of three equations, it means that there are three waves. There are three waves. Okay. And if there are three waves, it means that there are three lambdas, lambda 2, lambda 3. These lambdas decides the speed of characteristics. And the eigenvector W decides in which direction the speed is, in which direction the fluid is moving. So let me just see that, let me just see a problem, discuss a problem that lambda 1 is less than 0. It means that the fluid is moving from right to left. And lambda 2 is greater than 0, which is another eigenvalue. So it means that the fluid is moving from left to right. And the same is the case with lambda 3. Okay. So we know that from advection equation. Advection equation is very important equation to understand future problems. Suppose we have advection equation. We know that advection equation has characteristic x minus u bar t is equal to constant. So this means that when t is equal to 0, then we are on x-axis and the value is x naught. It looks like this. We have this x, we have this t. When t is 0, so we are on x-axis. On x-axis at particular location, we have x naught. So it means that above equation becomes x naught minus 0 c, which is a constant. C is equal to x naught. So x minus u bar t is equal to x naught, and x will be equal to x naught plus u bar t. And the characteristics, this characteristic will look like this. When x naught changes, we get these characteristics, so on. Okay. Now we move to our problem. Here, the first characteristic is, for example, x minus lambda 1 t is equal to constant. And we remember that lambda 1 is less than 0. So, in the same way, x minus lambda 1 t, we get x naught with the same procedure that I did over here. We follow the same for eigenvalues. Then x will be equal to x naught plus lambda 1 t. And this characteristic will look like this. This characteristic will look like this for some point on x naught. This is x naught, and we have the characteristic. This is the characteristic, and since it has negative slope, lambda 1 is less than 0, we get x naught plus lambda 1 t. The second characteristic, for example, we have x minus lambda 2t is equal to constant, and this equation become x naught plus lambda 2t. We follow the same procedure like this, or maybe like this. Since there are three characteristics, since there are three eigenvalues, there are three characteristics, there are three equations, so on, three waves. The point is fixed. So this point is fixed. When I draw this characteristic, its slope will be positive, but it is, since it is less than lambda 3, so its slope will be little bit higher, since uh, when we solve, for example, this problem, maybe I solve the same problem over here, this becomes x minus x naught lambda 2 t, and t will be equal to 1 over lambda 2 tx minus 1 by lambda 2 x naught. So when lambda 2 is small, its reciprocal is large. So the slope will be a bit larger than lambda 3. So its slope will look like this, but it should be positive, x naught plus lambda 2 t. So we write this x naught plus lambda 2 t. Remember that we are drawing these characteristics starting from fixed point this time. And the last one is obvious. You can write it yourself, x minus lambda 3t, which is constant. So x will be equal to x naught plus lambda 3t. And remember that we are talking about the fixed point. We are not saying that this one is x naught and this one is x1. The starting point for these characteristics is the same. So for this case, we have this characteristic x naught plus lambda 3t. So we write it like this, x naught plus lambda 3t. Now we know that this point, if there is some information, for example, uh, some density, then it means that that density will flow, will transport on these characteristics, and we already developed such intuition before. So this is called range of influence, that this point can influence this region only. It has no effect over here. For example, if some person is sitting here, then this information cannot travel to that person. But if someone is over here, then and if there is some characteristic, for example, there is some characteristic, otherwise if there is no characteristic, no one will hear no one will receive the information, because information only travels on the characteristics. If we have many characteristics like this, then the person can receive the information. But the idea is this point can influence only the region in between here. This is called range of influence. Range of influence. Thank you for watching.